And in addition, at every opening, at every turn, there is one extra exit to the surface. Now you see how complex these things are. And now to show you this, here just a few examples of the networks. And the networks also horizontal, very much like chicken wire, but in this case, in this very special form that we found presently at the deep sea bottom, you see the openings in such an arrangement that here are only the openings, and I'll show you some specimens where you see hardly eroded, then you see only these vertical outlets, or deeper you see the net. In another form, you have the outlets not in the middle of each connection, but at the branching points, but only after the second. First, outlet, second, no outlet, third, outlet, third, no outlet, outlet. And these are species. And now the question comes, and well, I have to go. This is the one that you saw in the previous picture. So it goes around like this, sinistral, opening at each, two openings actually at each turn, then the turn, and then dextral back. This one was more marked, more Greek. Small differences, and I could go on and on. Even these without the additional exits, they have, their ornaments are systematic, and every species is somewhat different, but you cannot tell what the difference is for, because functionally, whatever you figure, they are just equally fit. Why did they develop at all? And the answer is this. The key. My key is not functionally better than yours, but my key opens only my house. So it's possession and access to possession that is forbidden to other species. And every species has one key, and they may inherit even their possessions. What are the possessions for? In my interpretation, all hypothetical, these are mushroom gardens in a microbial sense. That means microbes are cultivated there, and these are fields that maximize with a certain distance, which is there, whether you make a complex meander or you make a net or whatever. There is this distance for the diffusion, and then you have the maximized surface in which the microbes can extract food from the pore water around that is not good for whatever animal has made the burrow system, but it's good for the microbes and they can be eaten. Just as what we do with farming. We cannot eat the earth, but the cabbage can, and we eat it. So, it's farming burrows in my interpretations. There are many others. Okay. Now the question, and I hope I have convinced you about the complexity of behavior that is expressed in these trace fossil patterns. Now, what happened at the KT boundary, Cretaceous, when all the dinosaurs, ammonites, and so on went? what happened in the deep sea? And the answer is nothing. Even that big event caused by the impact of an asteroid did not reach the deep sea. So that's time constancy. Now, the question is, what happened at other mass extinctions? And there is the Permo-Triassic one that is particularly interesting. Unfortunately, we have very few places in the world where we have deep sea deposit piled up by collision on the continents of Permian age. Some seem to be somewhere in Central Asia, but I didn't make it there. There is a locality in Sicily that I still would like to see. I happen to be at one in New Zealand, southern tip of New Zealand, very cold at that time in our summer, their winter. And there you have these outcrops there, which are Permian turbidites, flesh as we say. And they have highly tectonized, but they still have the trace fossils. And one of the most interesting ones is this one. Now, the beginner has a hard time to see that, to recognize that, because it's so deformed by tectonic stress. But it's a member of the group of trace fossils that is represented here called the volcanium. Now, I cannot go into the differences between species, but you see they are clearly distinguishable. Instead, I show you one little piece as a video. Now, given that area, and you have the worm coming, hit. So, retreats, eats, bite, up, bang. So, it always stops and retreats when it hits. Now, we could go on like this, but now we do probe by probe. Until at the end, something is in the room, says, me, you go too far, I'm not long enough. So it retreats, and we can do this field by field, and you see these palm leaves that result from that. One field, next field, next field, next field, next field, and go around in the opposite direction, hit them, and go on like this. Now, if this is not a complex behavior, you give me an example. And it was very successful, very highly developed during the Paleozoic, but never after that. A golden age phenomenon before the mass extinction. So we do have, in this case, the record, and this the same thing with certain mollusk-like organisms that had a feeding mode of moving deep in the sediment in certain meanders and feeding the sediment and pushing it back. But they needed a connection to the surface for ventilation. And they must have had a very long snorkel, like the submarines had it. But a flexible snorkel that was able to cut its own way through the sediment and follows the meanders at depth at a smaller scale near the surface. So this another very complex behavior pattern